Welcome viewers. In this video we will see the design of 4 into 16 decoder using 3 into 8 decoders. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Design of 4 into 16 decoder using 3 into 6, 3 into 8 decoder, two numbers. Right, we know that decoder is a device having n input and 2 to the power n output. N input and 2 to the power n output. Here n is 4, 2 to the power 4, 16. 4 inputs and 16 outputs. Here n equal to 3, 2 to the power 3, 8 outputs. 3 inputs and 8 outputs. So we need to design the 4 into 16 decoder. 4 input and 16 output decoder. So here 3 into 8. So 8 outputs are available. So that we are using two numbers. 2 into 3, 16 outputs we will get. Right? Two numbers of 3 into 8 decoder we are using. So here 4 inputs are available. Let us consider A, B, C, D. 4 inputs. A, B, C and D. Here we need 3 inputs. Only 3 inputs are needed. So we can use A, B, C as a 3 inputs. And D is used for enable these two, enable or disable these two decoders. We are using two decoders at a time. We can use only one decoder. Another decoder will be disabled. So this the input D is used to enable or disable the two decoders. So that we'll get the output from only one decoder at a given time. Now we'll see the logic diagram. So this is the logic diagram. We are using 3:8 decoder number 1 and number 2. It is named as top and bottom. Top decoder and bottom decoder having 3 inputs and 8 different outputs. 3 inputs and 8 different outputs. Right. So out of 4 inputs available in 4 into 16 decoder, A, B, C is connected as the input of this 3 into 8 decoder. A, B, C. First 3 inputs. The same input connected to the bottom decoder also. Top decoder and bottom decoder, the input is ABC. Right. One more input D is used for enabling this top decoder and bottom decoder. So it is connected as a enable input. So it is inverted. So it is 0. D equal to 0 means here 1 will be there. So the top decoder will be enabled. If it is 1, it become already one inverter is available. So this bottom decoder will be enabled. At that time here it become 0. Right? D equal to 0, top decoder enabled. D equal to 1, bottom decoder will be enabled. So while enabling top decoder, we will get 8 different outputs. Y0 to Y7. Right? That is D0 to D7. At that time bottom decoder is disabled. When bottom decoder is enabled, these outputs are 0. Only we will get these outputs. So totally we are getting from D0 to D7, then D8 to D15. 16 different outputs will be available. Right? So out of 4 inputs, we are using 3 inputs for these two decoder. 4th input is used as enabling this top and bottom decoders. So that we are getting output from one decoder at a time. At that time, the output of second decoder is 0. Similarly, while enabling this bottom decoder, we will get the output from this, and these outputs are 0. Now we'll see the truth table for the further understanding. So this truth table is available here. The D equal to 0 means top decoder is enabled and bottom decoder is disabled. So that we'll get the data from D0 to D7, D8 to D15 will be 0. If D equal to 1, bottom decoder is enabled and top decoder is disabled. Bottom decoder means we'll get the data from D8 to D15. At that time D0 to D7 is 0. All inputs, all outputs are 0. Right? So D equal to 0, we'll get data from D0 to D7. D equal to 1, we'll get the data from D8 to D15. Now we'll see the truth table. So this is the input A, B, C. A, B, C is connected to both top decoder and bottom decoder. This D is used for enabling the top decoder or bottom decoder. So this is the top decoder. D0 to D7. This is bottom decoder D9 to D15, right? We will see what will happen if D equal to 0. First combination D equal to 0. So the D equal to 0, in that time this top decoder is enabled. The all inputs of bottom decoder are 0. All are zeros, right? In this D equal to 0, another 8 combinations available because of 3 inputs A, B, C. There are 8 combinations. 2 to the power 3, 8 combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. So based on these 8 combination, we'll get the 8 different outputs here, right? We will see how it is we are getting. So D equal to 0, top decoder is enabled, bottom decoder is disabled. So output of bottom decoder, all the outputs from 8 to 15 is 0. Now we'll see how it will get the 8 different output from the value of ABC. 0, 0, 0 means the D naught will be 1. Other digits are 0. 0, 0, 1 means D1 is 1. D1 output is 1. Other digits are 0. 0, 1, 0 means D2 output. The terminal D2 output will be 1. Other digits are 0. 0, 1, 1 means D3 will be 1. Other digits are 0. 1, 0, 0. Then D4 will be 1. The D4 output will be 1. Others are 0. 1, 0, 1 means D5 output will be 1. Other digits are 0. 1, 1, 0. D6 output will be 1. Others are 0. 1, 1, 1 means D7 output will be 1. Other digits are 0. So based on this 8 combination, we are getting 8 different outputs starting from D0 to D7. D8 to D15 will be 0, right? Now if the D is 1, again another 8 more combinations are there. If D equal to 1, what happened? This bottom decoder is enabled now. The output of the top decoder, all the outputs are 0. All the outputs are 0. Only with the bottom decoder will get the output. So bottom decoder is now this disabled. Top decoder is now, top decoder is disabled and bottom decoder is enabled. Again we have 8 combinations are there. 0, 0, 0 means we will get D8 output is 1. Other digits are 0. 0, 0, 1 means D9 output is 1. Other digits are 0. 0, 1, 0 means we will get D10 output is 1. Other digits are 0. 0, 1, 1 means D11 output is 1. Other digits are 0. 1, 0, 0 means D12 output is 1. Other digits are 0. 1, 0, 1 means D13 output will be 1. 1, 1, 0 means D14 output will be 1. 1, 1 means D15 output will be 1. So that we are getting this 8 different output because of these 8 combinations of ABC when D equal to 1, right? So when D equal to 0, we are getting 8 different outputs, D0 to D7. When D equal to 1, we are getting another 8 outputs, D8 to D15. So totally we are getting 16 outputs, right? D0 to D15. So in this video we discuss how to construct the 4 into 16 decoder, 4 input with a 16 output decoder using 2 numbers 3 into 8 decoder, right? So out of 4 inputs, we are using 3 input for both the decoders. One more input is used for enable or disable the decoders 1 and 2. So that we are getting 8 different output when D equal to 0. Another 8 different output when D equal to 1. So totally 16 output we are getting. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the design of 4 line to 16 line decoder using 2 to 4 decoders. 2 to 4 decoder. We know that decoder is a device having n input and 2 to the power n output. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The decoder is n input with 2 to the power n output. Here n is 4 and output is 2 to the power 4, 16. 4 inputs and 16 output. We need to design 4 inputs with 16 output decoder using 2 input with 4 different output decoders, right? So here 16 outputs are available. Here the output is 4 outputs. So we need 4 numbers. 4 numbers of 2 to 4 decoders are needed. So 4 into 4 will get 16 output, right? Here how many inputs are there? If A, B, C, D, 4 inputs are available. Then 16 output. This 16 output will get 4 into 4 number of decoders, so we'll get 16 output. Then what about the inputs A, B, C, D? We are giving C and D, the LSB. The LSB, least significant bit, is given to input of all 4 decoders. C and D are given to input of all 4 decoders. These 4 decoders are selected by one more decoder. We need one more decoder in order to select these 4 decoders. That is decoder 1. So that is also one of the 2 to 4 decoder. In that A and B is given as a input, right? So out of 4 input, C and D is given to these 4 decoders in order to produce 4 into 4, 16 outputs. To control these 4 decoder, we are using one more decoder, 2 to 4, one more decoder. In that we are using the remaining inputs A and B. A and B 2 digit 4 combination. 0 0 means we will select the second decoder. 0 1 means we will select third decoder. 1 0 means we will select fourth decoder. 1 1 means we will select fifth decoder. So we can select this out of 4 decoder based on this combination. Now we will see the logic diagram. So this is the first decoder. We are giving A and B as a input. So we are getting 4 different outputs, D0, D1, D2, D3. This D0 is connected to the second decoder. When D0 is enabled, the D0 output is there, means the second decoder will be enabled. So that will get 4 different output. That is from D0 to D3. Suppose D1 is enabled. D1 is high output, means the third decoder will be enabled. So that we will get the output D4 to D7. D0 to D3 already available here. D4 to D7. At that time only one decoder will be enabled. Either this or that. Suppose this D2, the third combination. D2 is high level, means the decoder 4 is enabled. So that we will get the output from D8 to D11. Suppose D3 is enabled, will the fourth decoder, fifth decoder is enabled. So that will get the output from D15, D12 to D15. Right. So totally we are having 15. So here 5 decoders are available. The first decoder is used to select out of 4 decoders for the 4 different combinations. The inputs are A and B. Right. So based on this value, these 4 decoders will be selected. So 4 into 4, 16 output will get. Then C and D is given to all the decoder. All the decoders are connected with the LSB input C and D. Right. So now it is very clear. In order to get the 16 output, we are using 4 numbers of 2 to 4 decoders. So that we are getting 16 output. The least significant bit is given as a input C and D. To select these 4 decoder, we have one more decoder is available. That is numbered as now decoder 1. For that we are giving AB, MSB. So this first decoder will select the, out of this 4 decoder, it will select any one. So that will get the output. Right. Now we'll see the logic diagram. Now we'll see the logical truth table. So that we go for the further understanding. So this is the truth table available. The inputs A, B, C, D. There are 4 inputs. This is the 16 different outputs starting from D0 to D15. Right. We already know that this AB is given to the decoder 1. That is a selecting decoder. CD is given to the 4 different decoders. Right. So AB having 4 combinations 0 0, 0 1, 1 0, 1 1. Again CD having 4 combinations 0 0, 0 1, 1 0, 1 1. So totally will get 16 different output. Right. Suppose AB is equal to 0. AB equal to 0 0 means second decoder is selected. Other decoders are disabled. Only the second decoder is selected. Will get the output from D0 to D3. remaining outputs are 0. Remaining decoders are disabled. Only decoder 2 is enabled, will get the 4 different output. Decoder 3, 4, 5 all are disabled, will get 0 output, right? So A and B 0 0 mean decoder 2 selected will get the output from D0 to D3. How will get the output from D0 to D3? That is based on CD value. CD is 0 0, D0 will be 1, other are 0. 0 1, D1 will be 1, other digits are 0. 1 0, D2 is digit D2 is 1, other digits are 0. 1 1, D3 will be 1, other digits are 0, right? So based on this CD value, 2 digit 4 combination, we are getting 4 different outputs. All remainings are 0. Now the next case for AB. If AB is 0 1, what happened? Decoder 3 will be enabled. We'll get the output from D4 to D0. All other decoders are disabled. See this, only this third decoder is enabled. Second decoder, third decoder, second decoder, fourth and fifth decoders are disabled. Right. Now how will get the data from D0 to D7? Again 4 combination. 0 0 means D4 will be 1. 0 1 means D5 will be 1. Other digits are 0. 1 0 means D6 will be 1. Other digits are 0. 1 1 means D7 will be 1. Other digits are 0. So that we are getting 4 different output based on the CD value. Right. Now we'll go to the next combination of AB. 1 0. Suppose AB is 1 0. AB is 1 0. We'll see what happened. AB is 1 0 means fourth decoder is selected. So we'll get the output from D0, D8 to D11. Right. The second decoder is disabled. Third decoder also disabled. Only fourth decoder is enabled. Fifth decoder also disabled. Right. Now how we'll get this D8 to D11 based on the CD value. 0 0 means D8 will be 1. Other digits are 0. 0 1 means D9 will be 1. Other digits are 0. 1 0 means D10 will be 1. Other digits are 0. 1 1 means D11 will be 1. Other digits are 0. So we are getting 4 different output. Now the fourth combination of AB 1 1 mean decoder 5. Last decoder will be selected. We'll get the output from D9, this D12. D12 to 12, 13, 14, 15. D12 to D15. Right. How we'll get this D12 to D15? Based on CD value. CD is 0 0 means D12 is 1. Other digits are 0. 0 1 means D13 will be 1. Other digits are 0. 1 0 means D14 will be 1. Other digits are 0. 1 1 means D15 will be 1. Other digits are 0. Right. The second decoder, third decoder, fourth decoder all are disabled. We'll get the 0 output. Right. So finally we are getting the 16 different outputs are available. Starting from here we'll get the 16 different outputs. Starting from D0 to D15 we are getting 16 different outputs. Right. So this AB is used to select the decoder, either decoder 2, 3 or 4, 5. This CD is giving the 4 different combinations, right? D0, D1, D2, D3 like that. So that we are getting 16 different outputs. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.